Hey guys, it's Miss Fonstock here. I'm actually going to do your first set of the math notes. The title of this is Rational Numbers, but really the whole concept that we're going to be talking about today is called classifying numbers. And if you classify something, you're just giving it a name. And so in this case, we're giving numbers that we know in our real world names. Just to kind of add a little side note, when you classify something, it can actually have more than one name. For example, you could classify me as a teacher, and that could be my name. Or you could classify me as Miss Bonastock, or you could call me by my first name, which is Rachel. So although you can classify me and put me in these different categories, I have sometimes many different names. So I think that's like kind of the first good step that we need to take in understanding that these numbers can have many different names. All right, so this is what the front of your notes would look like if you were going to print it out and fold it. Here's just a picture that you can pause on. If you did print yours out, it just folds like a book. But if you are using Cami, then you are obviously ready to go on with me. And I'm going to do something that I normally wouldn't do, and I'm actually going to start in our notes at the bottom. I think this is much easier to understand if we start with the basics, and the basics are natural numbers. So when we think about natural numbers, we need to think about numbers that we knew before we even started school. And that would be numbers that you would just count with. And so when you count, and I'll write the word counting numbers. You need to remember, though, that when you were really, really, really little, before you went to school, these counting numbers were numbers that started with 1. And then you went to 2, of course, right? And then 3 and 4 and so forth. And so counting numbers, when your parents taught you how to count, you had to be able to see the item, like if you were counting jelly beans or gummy bears. And if you didn't see an item, you didn't count. So you saw your first gummy bear and you called it 1. Your second one is 2, and so forth. And then you get a little bit older and you start doing numbers a little bit differently and you add something to those. So you are now starting with 0. And so all that means is you've taken your counting numbers and you've added 0 to it. So it's the same concept. So you start with 0 and then just 1, 2, 3, 4, and so forth. So at some point, maybe like, pre-K or kindergarten, you were finally introduced to this concept of 0, having nothing. And so that is a whole number. Then, you start to kind of hear these numbers that don't really, you can't really see. You have a hard time understanding them. Like maybe your parents talk to you about temperature. And as you know, on a thermometer, like outside it can be really, really hot, but it could also be really, really cold. And so we start to introduce this concept of negative numbers. So we have our counting numbers. We have our numbers that are 0 and higher, like you keep counting. And then we have these numbers that are natural and they are whole, but then they are everything on the other side of the 0 marker. So it is all whole numbers and their opposite. And if you've never heard the word opposite, that is literally talking about the negatives. And so to list these out, I'm actually going to list them out in order. And we can do a ... because you can keep going in the negative direction. And so I could start with -4. And then as I'm going up, I go to -3 and then -2 and -1. And after that, I have finally reached 0. So as I'm getting closer to 0, then I switch and I shift into my positives. And again, these can keep going in both directions. They could keep going in the negatives, they could keep going in the positives. But to kind of help you understand opposites, 0 is right here in the middle, and 1 and -1 would be opposites. 2, -2, 3, -3. So every number at this point in your math career, now has an opposite. So all of these numbers can be thought of interchangeably. For example, if I said number 1, well, you could say number 1 is an integer. Number 1 is also a whole number. And the number 1 is also a natural number. So again, it has many names. But if I were to give it its final name, I would probably end up calling it an integer, because anything that kind of falls underneath integer is considered whole and natural. If I were to say the number 0, I could say, okay, 0 is an integer. Yes, we know it's also a whole number, but it is not a natural number. Does everyone see that it is not a natural number? Okay. So to move up to our notes, we've got this kind of broad, weird definition up here that we need to talk about. And it's the word rational number. So a rational number, guys, it's a number that can be written as a ratio. And I'm actually going to stop there for just a second, because I need you guys to understand what a ratio is. If you remember from maybe 5th and 6th grade, ratios can be written like this: 4:5 or 4:5. But in this point of your math world and going forth, so 7th, 8th, all of high school, all of college, I need you to know that ratios are fractions. So let's put that in parentheses. It's a fraction. So if I were to go back and read this word, rational number, I would say a number that can be written as a fraction. The only reason why we say ratio, guys, is because ratio is found in the word rational. Does everyone see that? Okay. And a lot of times you'll see the example given as A over B as a fraction. You can plug any number you want in for A, you can plug any number in you want for B, and it'll be a fraction. So, rational numbers can be written as fractions. I want you guys to understand that a rational number is an integer, and a rational number is a whole number, and a rational number is a natural number. But you're probably thinking to yourself, I don't see any fractions written there, Miss Fonestock. And that's true, but hopefully you guys remember that these numbers can be written as fractions. Does anyone remember the magic number that can be put underneath any of these numbers to make it a fraction? Hopefully someone said 1, but you are right. So if I take the the natural number 2, and I wanted to make it a fraction, it would just be 2 over 1. Or if I wanted to take a whole number, let's say 3, and make it a fraction, it would just be 3 over 1. And then finally, if I wanted to take an integer, and it could be positive or negative, but let's just do a negative for fun. Let's say I take -4, and if I wanted to make it a fraction, I just place it again over 1. So any of these numbers that we've talked about so far in your math career, from, being a little bitty preschooler up until now, all of these numbers are rational because they can all be made into a ratio or a fraction. Now, the last two I've left on purpose for last because they are decimals. Not a lot of people like fractions, and not a lot of people like decimals, but I promise you one thing, it's not so bad. So we've got two different types that fit into our rational number sheet. So terminating decimal is our first one, and I'm going to maybe I should underline it so it kind of stands out more. Terminating decimal. So a terminating decimal is a decimal that ends. If I could type, that would be helpful. So any decimal that ends, and what that means is it has stopped. Like the decimal doesn't go on anymore. So an example we could give is like 0.5. Or I could give 0.89. That also terminated or stopped. I can even have a whole number with it, like 34.3. So as long as that decimal in this case the 5, the 8, 9, and the 3, as long as they are done, they are ending, that is what we call a terminating decimal. And guys, believe it or not, they can be written as fractions. So just to kind of prove it to you, I want to pull up my Desmos calculator. So if I have the decimal 0.5, so 0.5, and I want to convert it into a fraction, there is going to be a way to do that. So let me make it larger actually. There we go. So if I wanted to turn it into a fraction, I literally am going to, I'm not going to want to hit that fraction button. I'm going to want to hit this fraction button. Does everyone see? And how it pops up, it says convert to fraction, and it's 1/2. So if I wanted to do the other one, which was 0.89, probably help if I could get it in there correctly, huh? 0.89, and then I could hit again this little convert fraction button, and it is 89 over 100. So if you remember that trick from elementary school, that's because it's in the hundredths place. And then last but not least, 34.3. And again, the convert to fraction button pops up, and it is 343 over 10. And again, because this is in the tenths place. So yes, although these are decimals, they can be converted into fractions. So what that means is terminating decimals are rational numbers. The last one we need to talk about is repeating decimals. And these are the decimals that you should also, again, know about, but they may just be something that we need to refresh your memory on. So a repeating decimal, it's actually going to kind of be the opposite of terminating, and it's just a decimal that repeats indefinitely. And that is a super fancy word for kind of infinity, right, you guys? It's just something that goes on infinitely or indefinitely, over and over again. We really aren't sure when it's going to end or if it even has an end. So as you guys know, these are decimals that look a little funny in your calculator. So let's give some examples of decimals like this. So an example of this kind of decimal, a common one is 0.333333. And that 3 in your calculator, sometimes it'll, pop up as like another 3 or maybe even a 4 because your calculator has ran out of room. And sometimes it, it needs to round up. But hopefully you guys remember that there is a special symbol we can write for these decimals to show that they do repeat. And so in this case, this one could be written, just like this, and then you just put a little bar over top of it. And that bar means that those 3s are going to keep repeating and keep repeating and keep repeating. So on to our next example. So if we have a new example, let's do, how about one that looks a little different? How about 0.454545454545? So that 45, again, in your calculator, it's going to look like it's going to go on and on forever and ever. But you could shorten it and put 0.45 because it's both the 4 and the 5 that are repeating. And then you just put a little line over them. A little line over it. So again, just to kind of prove this to you, I think it'd be helpful to pull up our Desmos calculator. And we are going to clear it all out. And let's put in the 0.33. If I hit the convert button on this one, it will come up as 33 over 100. So yes, it is a fraction. But again, like that 3 goes on and on and on and on forever. So some of the times, though, you will see a fraction that shows you repeating. And so I'm going to show you what that might look like. So 1 over 3. As you can see right here, that is the repeating 3. So it is a little different when you're going the other way around, but just know that you can still convert them both into fractions, both the fractions into decimals and decimals into fractions. All right, so that's pretty much all of the notes. In your Zoom today, we're actually going to go over this next section, which is practice. So kind of be ready for that. We have, already talked about most of these: decimals, the number 0, this repeating bar right here, negatives. We do have a mixed number, but don't be afraid of that. The Desmos calculators will let us do mixed numbers. But the only one we didn't talk about is this one with this, they call it a square root. You actually won't learn about square roots until you're in the 8th grade, but just to kind of show you, there is a square root button on the Desmos calculator. So again, we'll answer all of your questions and talk about this practice session on the Zoom. See you soon.